So you're well on your way through the course at this point. We're about halfway through the semester. And at this point, you've definitely experienced the trials and tribulations of being a programmer. You've made some little mistakes, you've made some big mistakes. And today we're going to be looking at all those different types of mistakes you've been dealing with and how to categorize them and really how to approach them. What to do when you run into certain types of mistakes and how to get through them. Now, sometimes it's straightforward. Other times it's not, and it's actually a real big slog to actually get through if you can solve the problem at all. Sometimes you just need some help, and that's okay. So, oops, I'm on the wrong thing here. So, as you may likely have noticed, your code does not always work or do what you expect it to do, though, and that can be a little painful. So this is a result of errors in your code. Yes, your code. Now, I want to be clear on this. A lot of times we get students who are like, oh, I think there's something wrong with REPL, or I think there's something wrong with Java. No, that's not it. That's not it, unfortunately. It's often easier to blame the language, the IDE, or something else than to acknowledge the fact that it is definitely, undoubtedly, your fault. All of us programmers make this mistake. Every single one of us has to realize that we're not perfect. And typically speaking, it just happens because we're rushing too fast. We're typing too fast. We make spelling errors and things like that. And that's okay. There's nothing wrong with that. It's okay to fail, especially when it comes to programming, because it's going to teach you how to actually not make that mistake in the future. But the truth be told, I still make the same mistakes that I've made 25 years ago because I type too fast and I miss something. And that's okay. Now, logic errors that we get into later on, where something's broken with the way I solve the problem, that's something else completely. So let's go on. So we're going to look at the three different categories that all programming errors fall into. The first one is syntax errors, then runtime errors, and finally logic errors. So over the next few presentations, we're going to actually discuss each one of these. And actually, by new presentations, I actually grouped them all into this one presentation. So that's all here. So we're going to talk about each one of these and how to avoid and or resolve these problems in the first place. All right. But before we do that, we need to understand that there's a few different, there's three different states a program can be at any one time. Only one at a time, though. So we can either be in the design time state, and this is actually before our code is running. So this is the code that we're writing, and typically this is when our code is compiled. So design time. We're designing the structure and the logic of our program. The next program state is runtime. So this is when the program is actually executing. It's actually running at that moment. And then finally, complete. The program is complete. It means it's finished executing and it didn't break with any errors. That's a good thing, hopefully. So we have three different stages, basically before, during, and after. Those are what we're looking at. And we're going to refer to these when we're talking about the different problems because each one of these three sets of problems occurs in one of those time frames. So let's start with the most straightforward, ones that you've seen the most, syntax errors, or also called compiler errors. We mentioned these on the very first day of school where we first started talking about what a programming language was and the grammar that we have to follow, which is called the syntax. A syntax error is an error that prevents the program from successfully compiling into machine code. And it usually occurs as a result of bad syntax. Really what that boils down to is you spelled something wrong or you put something in the wrong spot, things like that. This is by far the most common type of error. Usually we write too much code, we hit go, and there's like 17 errors that pop up because we were in such a rush. Well, that's just the run of the mill. It's the way things work. That's okay. These are the easy ones. They're no problem to solve. So what kind of errors are these syntax errors? Here's a short list, and it's not a complete list, but here's a short list of ones that you've definitely seen at some point. Forgetting some kind of punctuation. Maybe that's a semicolon. Maybe it's a quotation for a string. One of those types of things. Great. Spelling mistakes. Usually you spelled like a keyword wrong or something along those lines, or you spelled a variable wrong, or a subprogram name. You capitalized something when it should have been lowercase. For example, like the word next line, input.nextLine, that L needs to be a capital. If you accidentally forgot and made it a lowercase, the Java compiler would not recognize that and would say, nope, syntax error, fix your problems. Incorrect or incomplete parameters when you're calling a subprogram. So let's say we're calling math.pow. Well, if we don't give it a base and an exponent, it won't work. It'll say, nope, I refuse. When you're trying to use a non-static variable or subprogram inside the main. So let's say you created a global variable, but you forgot to make it static. Well, we've all seen that error pop up. Same thing with your subprograms that you create. They also need to be defined as static. Forgetting a return statement in a function. That happens. If you don't have it, it's going to say, sorry, I can't compile. You forgot something pretty important. Unreachable return statements. So usually this happens because you have your return statement inside of an if statement, and the compiler is just trying to tell you that, you know what, there's a chance that this return statement will not get executed. So this is an unreachable amount of code. You also see unreachable code inside of switch statements. If you, for example, you have your break command and then you put some code after the break command, well, break tells you to get out of the switch, which means any code after the break is physically unreachable. It can't be reached. So you might get that kind of syntax or compiler error as well. Okay, so those are the most straightforward. Let's see how well you learned your lesson. So here's a chunk of code, and there are about 8 errors on this. I want you to pause the video and see if you can find all 8. I'll wait here for you. Okay, I'm assuming you're back now. Okay, so let's take a look. We've created 2 variables, one called phone number and one called age, both of them integers. So age has a value 21. Phone number we set on the next line. Or do we? We don't actually. We spelt it wrong. So we missed the O. So this actually would give us a compiler error, a syntax error, saying it can't recognize this phone number. The next one is one that's a little bit less obvious. Remember that these variables are integers. Now, if you remember from class, when we first learned variables, how big can an integer get? Well, the maximum size of an integer is about 2 billion, a little bit more than 2 billion, but it's about 2 billion. Well, this number, which we know is a phone number, but if we're trying to store it as an integer, is too big. It's about 4 billion. So that's actually an error saying it's too big to fit inside of an integer. The next one is a spelling error. If that I should be a lowercase I. And then the next one is our operators. So when we want to say if age is greater than or equal to 18, we have to do the greater than sign first. So this should be greater than and then the equal sign, not like this. Okay. Now we're missing an opening brace, the opening squiggly bracket. It's just not there. Println. Well, what? We're missing something. We're missing the system.out. It's completely not there. You are over 18. We forgot our quotes. Finally, we forgot our semicolon. There's 8 different errors in 3 lines of code. 8 errors in 3 lines of code. And I get code that looks like this from students on a daily basis. They're just in a rush. Mr. Lane, I don't know why my code's not working. Can you help me? And sometimes I will. Sometimes I'll refer students back to a previous lesson saying, no, go look at this. You should know this by now type thing, right? Okay, so there's our compilers. Again, these are the easiest ones to solve because when the compiler fails, it actually tells us where the error is, tells us the exact line, and even gives us a hint as to what the problem is. And that hint's usually pretty close. It is still a guess though. It's not always perfect. Okay, the next one is while the program is running, runtime errors. So a runtime error occurs while the program is running, usually when the program attempts an impossible operation. Impossible operation? What? Well, what do we mean by that? Well, it's something that you try to do and the computer's incapable of doing it. What happens when you do this? Well, the program typically crashes. This is super jarring for the user. In fact, it's the most jarring type of error because this is one that actually impacts the user as opposed to us as programmers. It physically stops them from being able to use the program. You've done this before. You've been playing a video game or using some kind of software and it just goes away. It crashes. It just completely dies. Well, that's not good. That is probably the worst situation that we can think of as programmers when our customer is not able to use the software we built. So let's look at a few examples of runtime errors. Things like dividing an int or a byte by 0. Well, this will actually say, nope, it will actually physically crash and your program will just not work anymore. And you get a divide by 0 error. Notice I said interbyte. You can actually divide a double. You can divide a double by 0, and you won't get a good number. You'll actually get the value infinity. So if you actually said system.out.println your double divided by 0, you would actually get the word infinity show up on the screen. So it's not really useful, but it doesn't crash your program. So the next one is an out of bounds error. We see this when we try to access an element of an array that's past the array, or a character of a string that's past the end of the string. So if we have a string that says hello and we try to access index 7, well, that index doesn't exist. If we have an array of 3 items and we try to access index 5, that index doesn't exist. So that would give us an out of bounds error. And then finally, or not finally, I guess, next we have storing an incompatible type in a variable or an array. So if we try to shove a string into an integer variable, obviously it doesn't fit. This is that square peg in a round hole problem. Just not going to work. A null pointer. Well, you probably haven't seen this one yet, but you may going forward. So imagine you had an array of strings, okay? And you tried to access an element of that array to display it on the screen. But what if you didn't give a value to that element of the array yet? Well, it doesn't have anything to display. So what's actually stored there is what's called a null value. Null means nothing, less than nothing. It's kind of like void. It just means nothing. The same thing happens when we have an object. Now, we haven't figured out how to really create objects yet, but if you have an object that has been set to a value, the same thing occurs. If you try to do something with it, act with it, work on it, you're going to get a null pointer because its value is null. Its value is nothing. Now, finally, trying to convert an invalid string to a number type. So if you try to convert the quotes 7.5 to an integer, it can't do that. It can convert 7.5 to an integer, but not the string 7.5. It won't work. Just like trying to convert Bob to an int. I can't store Bob in an int. No matter how hard I try, it won't fit. Okay, so runtime errors. How well have you learned your lesson? Let's find out. So there's a few runtime errors here. So 2 really that happen because of something else. So I'll give you a couple seconds to see if you can figure this out. Pause the video and take a look. Okay, hopefully you're back now. Now looking at this, the first error we see, hopefully you see this, is right in here. We are trying to parse whatever the user types in into an integer to store it into total pay, which is an integer. But what did the user type in? The user typed in 685.50. But remember, input.nextLine gives us text, a string. So it's trying to convert quote 685.50 into an integer. And that will not work. We saw that on the previous slide right here at the bottom. We can't put a double value that's in a string form inside of an integer. It won't work. So that's the first error. The next error is a divide by 0 error. We did total pay divided by hours, but we forgot to actually change the value of hours anywhere in here. We didn't ask the user for it. We didn't give it a value. So it's actually dividing by 0 here. And it's an total pay is an integer, so the whole thing fails. Does not work. No good. So those are some simple and quick runtime errors. There are so many different types of runtime errors that there's no way for me to cover them all. You're going to encounter them, and you're going to have to deal with them one at a time. But they're not too bad. They're just a little bit more challenging than your syntax errors. But then we get into the rough ones, the logic errors. These are the ones where you go to bed cursing your teacher's name. You're like, I cannot believe this. I hate this class. I hate you, Mr. Lane. I hate you, Mr. Finley. I refuse to work on this stuff anymore. You get a good night's sleep. You wake up and you're like, oh, how did I miss that? And you solve the problem. Boom, just like that, usually. So these are the tough ones. These are the ones that they're so tough that sometimes we don't even know they exist. So a logic error is an error that prevents the program from doing what is intended to do, what it is intended to do. And it produces unexpected results. The big thing about this is most of the time, we don't even know that the error exists. That program could actually be in the wild in our consumer's hands, and somebody just didn't hit the proper button combination to make it visible for years even. It happens all the time. So people are finding bugs in Windows that were there, 7-10 years ago, but nobody noticed it until now because nobody did that perfect situation. It happens. So logic errors. Oops. So this could be something nice and simple, like adding when you meant to multiply while you're calculating the area of a rectangle. Well, you just put the wrong operator, no problem. Or it could be something much more complicated, like detecting when two objects collide. If they pass through one another, that's a problem, right? So something much more complicated, like two objects passing through one another in a game that should have collided. That is a logic error. They should have stopped. Why did they not stop? So the program actually still runs. It still finishes. No error is reported. So how do you fix it? How do you even know that it exists? There's actually a certain amount of luck involved here, but there is some proactive approaches that we can take to make sure that we don't actually get these problems. So because these errors don't actually break our program, they will actually go a long time without ever being found, or they can anyway. These simple properties of the fact that we don't know they exist makes them the most challenging to find and fix, because you don't even know that they exist and you don't know where the problem exists even when you do know it exists. How do you find it in the code? If your code's 50 lines, sure. If your code's 50,000 lines or 50 million lines, well, that makes things a little bit more complicated now, doesn't it? But that's the nature of the beast. So let's look at the next set of code and see if we can pinpoint any logic errors here. Remember, a logic error is just an error that causes unexpected results. And let's see. Give you a little bit of time to try and find these. So pause the video. All right, back. So let's see what we found here. So hopefully you see the first obvious one. Radius still has a value of 0, which means when we do multiplication, well, that result is going to be 0 every single time, no matter what, because we're multiplying by 0. So that's no good. So the next thing is that the equation is wrong. We're calculating area. The area of a circle is not 2 pi r, that's circumference. It should be pi r squared. And there's one last one that I bet most people missed. We're displaying the wrong value. We should be displaying area there, and we're actually displaying radius. So a wrong variable displayed. So these are very common logic errors, and these are about as simple as they come. All right? Every single one of you has written code now at this point, and every single one of you have looked at the code, say, this should work. Why doesn't it work? I don't get it. That's because you have a logic error. So what are the strategies? How do we actually solve these problems? Well, the number one thing to realize is the best solution to combating errors is proactive testing. Test your program in all ways that you can possibly think of that the user will ever use your program. And then when you've done that, test some more. See, here's the thing. When we're building our programs, let's say, I'll give you something that most of you will understand. Let's say you're building a program like a big, massive role-playing game, like Skyrim or something like that. Now that game probably had 200 testers on it that tested for thousands of hours. And let's say, just hypothetically speaking, let's say every single one of those 200 testers tested for 1,000 hours. That's 200,000 hours worth of testing. You might be like, wow, that's a lot of testing. Okay, sure. Now what happens when 10 million people get that in their hands the first day? 10 million people. If 10 million people tested it for 1 hour, well, that's 10 million hours worth of testing versus your 200,000 hours of testing with 200 people. So no matter how much we test, we can't possibly hope to do the same stress testing that the public will do on our software. So we do the best we can. We try and find everything, and then we realize that we're probably not going to be perfect, so we're going to have to release patches and updates to fix our problems. That's fine. There's no way you haven't played a game that doesn't do that. That's okay. Even Windows releases updates and patches all the time. It's okay. So how do we solve our errors? Let's break this down into two categories. First, the easy ones, compiler errors. These are the most basic ones. When the program will not compile, you get a nice message, a line, you get a line number, and you get an error description of what will probably be the problem. Usually that'll say something missing semicolon, or the brackets don't align, or something along those lines, or I don't recognize that word because you spelt it wrong, something like that. It tells you, it gives you a hint. It may not be perfect, but it's definitely going to be helpful. All right? So here's a couple strategies. Number one, always start with the top error. Don't go to error number 3 just because it looks easy. Start with the top error, because the chances are that error is causing other errors that aren't actually errors. They just look like they're errors to the compiler because the first error caused different problems. So it just kind of cascades through everything. So fix the first error. When you're done fixing any error, test your code. Run it again and test it. Chances are a whole bunch of errors are going to disappear because they weren't actually errors in the first place. So those are the nice ones. Now, runtime errors and logic errors. We're going to group these together because we can approach these in very similar ways. First up, a runtime error will tell you where the issue was in an error message. It'll actually give you a handy message because your program just crashed. And it's going to give you an idea of where it crashed for a runtime error because it crashed on one specific line. So you just have to read the comments inside the console to say, well, where did it crash? If you're using Eclipse, it actually stops on the line and highlights it in big yellow. So you're like, oh, there's my problem. So that's an advantage of Eclipse, obviously. Logic errors, we don't get any kind of feedback saying, well, this is where your problem is. So how do we find it? Well, we have to be able to recreate the error. So as testers, once we've realized that we have a problem, we have to be able to go recreate that problem effectively so then we can pinpoint, well, it only happens when I do this. Okay, so let's go look at, quote, this, and backtrack to figure out where this got its value, and then where that value, how that value is calculated, and so on and so forth, till we get to the line where the actual issue is. So now if we're at this point where we've got the line from the runtime error message, or we got the line from backtracking where we saw it on the screen, we're at that point. So how do we actually deal with it now? Well, you got to analyze that line. Look at all the data on the line. Look at all the method calls on that line. What type of information is it? What type of data is it? What's actually stored in the data? Analyze it. What doesn't make sense? Which one of these things is not like the other? What you want to look at is which value is incorrect and why is it incorrect. So check their type, check their values. Work your way backwards until you find how that value was actually calculated or where it came from. If it came from the user, if it came from a file, if it was calculated in some way, how did it get that value? And then you got to keep going back. You got to keep working back so you can figure out, well, what went wrong here? Was my calculation wrong? Did I have the wrong operator? What went wrong? So in essence, what you need to do is you need to step through your code one line at a time. Once you've found that error, actually work through the program one line at a time. And again, if you're using Eclipse, you can actually do this visually on the screen. If you're not, if you're using REPL, you may actually have to do that just by looking at your code and pulling out a pen and piece of paper and writing down your variables and tracking their values as you go so you can keep track of what's going on, when, and all that kind of stuff. Now, there is ways that even in REPL you can get some feedback from your program about where it crashed. So make use of temporary output statements. So just throw like literally system.out.print lines in the middle of your program all over the place to either output the current values of variables, or maybe it's just kind of like a checkpoint. So let's say I know an error occurs in a certain subprogram. I don't know where, so what I'm going to do is I'm going to output a whole bunch of system.out.print line statements in that code to figure out how far it gets before it stops executing the code I expect it to. So maybe I have it output just letters, A, B, C, D, E, F, but it only gets to C. So why didn't it get to D? So then I can go look at that, and somewhere in between C and D there was a problem. So that means I can track down the error to help me find the error. So use of temporary output statements. And now you may be like, this is ridiculous. Well, if you code in any language like C++ or things like that, that's kind of the norm. That's just the way people do it. It depends on the luxury of tools that you have, and sometimes it's a little bit easier in other cases depending on what you're working with. Visual Studio for C#, Eclipse for Java when we're actually working normally. But REPL does a pretty good job for the most part. So that's it. Those are all the different types of errors we've experienced. Your homework is going to be to fix a broken piece of code. And when I say broken, I mean, oh, it's broken. Good luck with that. Have fun.